Hi students, today we are going to discuss about logarithms. Our topic is logarithms. So very important and interesting topic. So before going to the logarithms, so what is the definition? So let me take exponential form. What is an exponent? Exponent, or index. Let me consider now. Suppose if you have 2 is multiplying 4 times, 2 into 2 into 2 into 2, that is 2 is multiplying 4 times, repeatedly multiplying 4 times. This can be written as 2 power 4. So what is its value? 2 power 4 is equals to, so 2 2s are 4, 4 2s are 6, 4 2s are 8, 8 2s are 16. So answer is 2 power 4 is equals to 16. So we know this is called exponentation or exponents. This is called exponents. Where 4 is called exponent or power. Then 2 is known as base. Then 16 is known as value. So value. This is called exponential form. So the given number is expressed as 2 power 4. That means, so 2 is raised to the power 4. The 2 is raised to the power 4, or 4 is raised to the base 2. It can be, answer is 16. That is 2 power 4 is equals to 16. Now, what is the logarithm? So, logarithm is nothing but inverse process of exponent. For example, if you take x value, if you add this one, x is x plus 2. If plus 2 is added to x, so to get x value, what we are going to take this one? So, we are going to take, so x plus 2 minus 2, subtraction, we get x. To get x means, so when you add 2 to the x, if you get x, if you want x, then we have to do subtraction. That is called reverse process. Suppose x is multiplied by 2. So this is one value. X is multiplied by 2, we get 2x. So from this we are going to find x again. So what we have to do? So we are going to divide by 2. That is 2x by 2, that is x. 2x by 2, that is x. That means what? This is the reverse process. So like this, like that. So the reverse process of exponents is nothing but logarithms. But now, how to change exponents into logarithms? Now we have to see how to change exponents into logarithms. Suppose here we are observing that 2 power 4 is equals to 16. So logarithmic form. This is exponential form. This is exponential form. So what is the logarithmic form here? Exponential form and logarithmic form. So let us see. Now what is the logarithmic form? To observe this one. What is the logarithmic form? Let me see that is. So to obtain logarithmic form from exponential form, so we need to change the base from here to here. So that means 4 is equals to logarithm of 16 to the base 2. 4 is equals to logarithm of 16 to the base 2. So this is called logarithmic form. Logarithmic form. So if you take another number like this, this is 10 square is equals to 100. 10 square is equals to 100. So 10 is repeatedly multiplying 2 times, or 10 is multiplied 2 times. So 10 into 10 becomes 100. So now, so what is that? logarithmic form. So by changing the base from here to here, that is 2 is equals to logarithmic 100 to the base 10. So this is logarithmic form. This is logarithmic form. So exponential are converted as logarithms. So this is now who introduced this logarithm? So this logarithm is introduced by John Napier. So John Napier introduced this logarithms. John Napier introduced logarithms which are calculated to base e. So logarithm of any value to the base e. So logarithm of any value to the base e. So this is called as logarithm of any base to base e. So generally we can write as ln x, ln x or logarithm of both are same. Logarithm of x to the base e or ln x is both are same. So John Napier introduced these logarithms, and Briggs introduced logarithms which are calculated to base 10. So which are calculated to base 10. So logarithm is defined for different bases. If any logarithm is calculated for base 10 is called Briggs logarithm or common logarithm. So this is called natural logarithm. This is called natural logarithm. So natural logarithms are introduced by John Napier, and Briggs common logarithms are introduced by Briggs. Very most important bits in 10th class level. So now in various fields logarithms are used. What are the applications of logarithms? Let me check. Applications of logarithms. In which fields applications of logarithms will be exactly used? Science and technology. First one is science and technology. To estimate the earthquake, to estimate the earthquakes on the Richter scale. To estimate the earthquakes on the Richter scale, it is very useful. And also large type of celestial bodies navigation of celestial bodies. So navigation of celestial bodies, and also expressing large numbers, expression of large numbers, we are going to use logarithms. So now, what is the definition of logarithm? Definition of logarithm. Here, let a power x is equals to n. Let a power x is equals to n, where x is a power and a is any value. So a is any base. If any number n can be expressed as a power x, that means any number n can be expressed as a power x is nothing but exponential form. So whenever exponential form exists, then only logarithmic is exist. Otherwise logarithm cannot be exist. Okay, so a power x is equals to n. So where any number n can be written in the form of a to the power of x. So a to the power of x. Then we can write. So simply we can take it as implies. So this is the condition of if then implies. A power x is equals to n. Then we can write logarithm of value n to the base a is equals to x. So for logarithms, say here x is exponent value, here a is base value, and n is any number. If any number is expressed as a power x, then logarithm of that number to the base is equal to that exponent. logarithm of that number n to the base a is equals to that exponent. So that that means what it is behind that. So logarithm of any value gives power value, that is exponential value, answers as exponents. So this is very very important definition. This is the definition of logarithm, where the condition is where the condition is where n is greater than 0 and a is greater than 0 and a is not equals to 1, where n greater than 0, where n greater than 0 and a negative values, logarithm negative values does not define, that is non-defined, that is not defined, not defined, negative values is not defined. And if you take base a less than 0, that is negative value, and it is not exactly 1 also, not exactly 1 also. Now the properties of logarithms we can see. So properties of logarithms. So under the properties of logarithms, properties of logarithms, properties properties of logarithm. First property. So logarithm of any product, logarithm of xy to the base a, so can be calculated as, logarithm of product can be calculated as log x to the base a plus log y to the base a. Logarithm of any product will be written as logarithm of individual sum, logarithm of individual sum. So here product involving xy, here sum involving x is separately and y is separately, that is log x to the base a plus log y to the base a. So how to do this one? So to this problem, so we know very very simple formula, a power m into a power n is equals to a power m plus n. So this formula we are going to use. A power m into a power n is equals to a power m plus n. Let here, let a power m is equals to x. When a power m is equals to x, according to this condition, what is the logarithmic form? Then log x to the base a is equals to m. Log x to the base a is equals to m. You can take it as first condition. Next, coming to a power n is equals to y. This is also let we are going to consider. Then what it happens? Log y to the base a is equals to n. So this is second condition. So a power m I am going to take it as x and a power n I am going to take it as y. So when a power m is equals to x and a power n is equals to y, so these two values substitute in this formula, what becomes in the place of a power m, x can be written as, in the place of a power n, y. So this is x into y is equals to, what is the value? A power m plus n. A power m plus n. Here xy is equals to a power m plus n. How to convert this as into logarithmic form? So this is converted into logarithmic form is log xy to the base a is equals to m plus l. So this is by changing the exponential into logarithm. So now what is the m value? So m value is here, that is from the first equation. This is log x to the base a plus, what is the n value? This is log y to the base a. Now what is the LHS side? Log xy to the base a. This is the formula we prove this is. So logarithm of xy to the base a can be calculated as log x base a plus log y base a. So to prove this formula or to prove this property, we have to know a power m into a power n is equals to a power m plus n formula. Then a power m is equals to n and a power n is equals to y. We are going to convert this exponential to logarithms by taking 1 and 2 equations. So now a power mx and a power n is equals to y. We are going to substitute that in the place of a power mx and a power n is equals to y here. Then the value will be taken as it is. Now we are going to convert this exponent also will be logarithm. then we get the value. So I hope you understand this one. So another property is division property. If you take divide x by y to the base a, so it becomes a subtraction log x base a minus log y base a. Then so we have to use this formula now here. A power m by a power n is equals to a power m minus n. A power m minus n. So for this also we are going to take same value here. A power m is equals to x and a power n is equals to y. Then log x base a equals to same up to this same. Then here only simple condition is x by y is equals to, this is minus. So because this is x by y is equals to, this is because this is x and this is y, we have taken x by y is equals to a power m minus 1. Then here also same we are going to consider, this is x by y log x by y. So a can be shifted like this is a power minus m. So this is also x by y and this is minus. So how simple it is. So very important. So how very important to proof of logarithmic properties. So this is second property. So we completed first property and second property. Now we have third property now. Let me check. So how to solve? Can you understand this one? Very simple this is. So as previous. Now so coming to third property. So third property is, it is also very simple. It is also very simple. So coming to third property, logarithm of x power n to the base a can be written as n into log x base a. So this is the definition. Log x power n to the base a is equals to n into log x base a. This is the property, or that means the power of logarithm, the power value of logarithm can be taken as n is friend, that is n into log x base a multiplied. So next, simply we can take it as, we know that the formula, we know that a power m whole to the power of n is equals to a power mn. So this formula we are going to consider. A power m whole power n is equals to a power mn. So under this formula we are going to calculate it as, let a power m is equals to x. Let a power m is equals to x. A power m is equals to x. So by changing this one, a power m is equals to x, a power m is equals to x, then we can written as, so we can written this as m is equals to log x base a. M is equals to log x base a. Now in the place of a power m, so we are writing x here. Then from this one, x power n is equals to a power mn. A power mn. X power n is equals to a power mn. So now this is the value. This is a. A can be taken as like this. So what it happens now? So what it happens? This can be written as log x power n. Log x power n to the base a is equals to mn. So where mn can be written as n into m. Where n into m can be written as log x to the base a. Log x to the base a. This is log x power n to the base a. Log x power n to the base a can be written as n into log x base a. So according to this formula. So now what we are doing here, a power m whole power n is equals to a power mn formula we are going to use. Then in the place of a power m is equals to x we are taken. Then if you take a power m is equals to x, then it is obviously correct, that is logarithmic form m is equals to log x to the base a. But I am taking a power m is equals to x. That means in the place of a power m, I am going to substitute x. X power n is equals to a power mn. So now we are taken x power n as a value, and the a power mn is base and exponent. Now we are changing this base and exponent into logarithmic form. While taking a this side, it becomes log x power n to the base a is equals to mn. Mn can be written as mn and nm, both. Nm I am taken. So in the place of m I am taken log x to the base a value. Now this is satisfies the formula. These are the properties. So if you know how to convert these properties, and if you know how to convert exponential into logarithms, so we have several formulas. So for example, simply we are taken a power 0 is equals to 1. We know this formula very well. A power 0 is equals to 1. But a power 0 is equals to 1. So what it happens? So logarithmic 1, this implies log 1 to the base a is equals to 0. Logarithm of unity to its any base is 0. Logarithm of unity to its any base is 0. So this is also very important formula. Then you can take another formula. A power 1 is equals to a. A is multiplying only one time, it becomes a. A power 1 can be written as a. So now by changing this into logarithmic form, log a base a is equals to 1. So what it indicates that logarithm of any value to its same base is equals to 1. Logarithm of unity to its base a is equals to 0. Logarithm of a to its same base is equals to 1. So in further classes we are going to explain more about logarithms. So keep watching. Thank you.